Hi, this is Thomas from Apex Game Tools. This is the second video on serialization in Apex Utility AI. In this video we'll be looking at how you can enable serialization of external types. So in the first video you saw how you can serialize types that you have control over by decorating the various fields and properties with an attribute. But for external types, that is, types defined in some other assembly that you do not have control over, you can't really do this. So we're going to build on the example from the first video. We have our qualifier here, and we have some custom settings. But now we have another class. So as you can see, we have our custom type, and this one has a few, one field and one property. It has a field, it has a type of external primitive type, and it has a property of external composite type. Now these aren't actually external, they are some types that I've created, but they are to mimic external types that you cannot control. So let's have a look. We have a primitive type here, a struct, simply has a float value in it. And then we have a composite type that is comprised of two properties, a name and a position. So we want to be able to edit these on our custom type. So if we switch back to Unity and we select our custom type, we now have the editor representation of these properties. But they're not very useful as they are now. As you can see, the name position that we had, it's just an entry here that we can't really do anything. We can't set any properties, and the same goes for the primitive down here. We can't set any properties. We can delete their instances, but that doesn't really help. This is because it has no way of knowing how to show these, because we can't decorate any of the properties with the serialization attributes, so we have to do it another way. Now there are two things to do here. One thing is to have them show up in the editor so that you can actually edit them in the inspector, and the other thing is to have them actually serialize and get saved, serialize themselves to a JSON. So we'll be looking at that next. So let's start by looking at how you can make them show up in the editor. Now the editor has some different types that it can render by default, but obviously unknown types it doesn't know how to render. In order to define how to render these, you need to create your own renderer, and the easiest way to do that is to derive a class from a class called Editor Field Base, which then is a generic type with a type argument of the type you actually want to edit. You can also implement this from the ground up, implementing an interface called iEditorField, but we will not be covering that in this video. That is a little bit too advanced. So let's start from the top. One thing to note is that you can see it is decorated with an attribute called types handled. This needs to contain the types that this field renderer handles. In this case it just handles one external primitive type. It could handle more types if they can all be represented the same way. Typically though, you will just handle one per editor field. Next up you have, well, the constructor. It has to look like it does here. And then you have the overridden method that you need to override in your renderer. This is basically where you render the field. In this case it's pretty simple, because our primitive type is basically just a float wrapped in another struct. So we simply write a float field, and then if the value is different from our current value, we update it. Now you need to do this, well, you don't need to, but you should do this test in order to not mark anything as dirty when it's not. So test that they are different before you actually update the value. Now similarly, we have the composite field. Obviously it's a little bit more complex because it has two fields or two properties in it. It's not just a wrap around one value, but other than that it is very similar. As you can see, we have the same declaration of types handled, derives from the same type, but there are a few differences. Well, first of all, obviously, since this is a reference type, we need to make sure that we do not have a null value, because otherwise we'll get a null reference exception. So if it is a null, we'll just write out null. If it isn't, we're just going to render the UI, and since it's comprised of two properties, a text name and a position, which is a vector 3, we simply write those two fields. And then finally, again, we do a test to see if anything changed, and if it did, we update the value. Now, one thing to note here is that since this is a reference type, we actually create a new instance of the type with the new values, because simply updating this with the value wouldn't change anything since the value hasn't changed. It's a reference type, it's still the same reference. So for reference types, you will have to create a new instance with the new values. So if you don't change all the values on the type, then you will be sure you need to clone it first and then set whatever has changed. So, having done that, we can switch back into Unity and see how that looks. So now, as you can see, we have the fields represented here. We can now edit them, write stuff into them, and it's going to work as expected. But what about serialization then? So let's start it. Starting the AI will serialize it and deserialize it. So when we get back from running, we'll see, oops, it actually didn't serialize it. So they're back to their defaults. So this brings us to the next task. We actually need to make them able to be serialized as well as being shown in the editor. Now, the way serialization works in Apex Utility AI is that when a type is serialized, it is first staged, and then from the staged form, it is then serialized to default JSON. It could be anything else. You can write custom serializers as well. And the same goes the other way around. If you read it, deserialize it, it is first staged, and then it is unstaged to the type that it is. Now, there are two different forms of types. You have simple types that are just represented by a name and a value, and then you have more complex types which are represented by a name and then multiple values. So for the first one, in this case our primitive, external primitive, which was just a float or a struct with a float inside, we can represent this by simply a name and a value. So for this we will use a converter. We need to convert it first to its staged form, and from its staged form to its actual value. So you need to implement a class create a class that implements the iValueConverter interface. The first thing it has is similar to what you saw in the editor. It has, in this case, instead of having an attribute decorated, it has a property that returns the types it handles. In this case, it handles the external primitive type. And then it has two methods, fromString and toString. So fromString, you get the string representation of the value, and then you then need to convert it to the actual value. Since, in this case, our value is actually a string, a float, we simply convert the value to a float, and then we return our primitive type with that float as an argument. Conversely, on the toString method, we get the value of our primitive, and then we return a string of that value. Obviously, these two methods work together. So this one up here expects that value is a float, and this one down here actually also writes out the float. Had it written the entire type represented some way, obviously the value up here would also have been needing to pass it in a different way. So that's the simple one. Now for more complex types, as we have with our composite, you need a different type called a stager. It does a similar thing, but just for more complex types. So it works the same way as you can see with handle types, but it has two different methods that you need to implement. It has a stage value and an onStage value. It is very similar to and from string, but instead of returning a string, here we return a stage item. And this is the staged representation of an object. We won't go into details too much about them. You can see them in the API documentation, the different types. But an item basically represents anything. Then we have elements which represent more complex types with multiple fields of properties, and values that just represent single values. Now in our case, we will be creating an element with the name of our property, and that element will have two additional elements. One will be an attribute. We'll give it, you could also simply have made it a value, but just to show the different options, we have put it into as an attribute. So it will have an attribute called name with the name value, and then it will have another element as a child called position, because position is a vector 3, so it cannot be represented by a single value. It will actually be represented itself as a stage element. So this is why we call this stage method instead. That will actually stage this value the same way this one is being staged right now. And then conversely, we have the onStage value, which does the opposite. It will then receive an element that looks like this. And then to unstage that, the first thing we do is we cast it to an element, because we know that is what it is. And then I return a new external composite type with name being the attribute value of name, and position being the unstaged value of the position item. So this basically passes this item into a vector 3. And that's it. We're done with our types, and the engine will now know how to serialize these types back and forth from JSON. So if we go back into Unity, just had a small compile error during our little session here. Let's just fix that one sec. So the reason we had that error was that we did these things in separate steps. Obviously you want to do this in one step so that you have your serialization ready when you have your editors ready, so that actually knows how to serialize, so it doesn't serialize the wrong thing. So here we are. We now have both things ready, so I can now write some values in here, and if I start and start again, I will now have it all serialized. So that's it for serializing external types. There is one last thing to note about external types. If you want them to show up, there's actually one additional criteria. They need to be in an assembly that is decorated by an attribute called the Apex relevant assembly attribute. It looks like this. It's attached to the assembly, and this will enable the AI to find types within that assembly. This does not apply to the default assemblies, assembly C# and assembly C# first pass, but if you do expose your types from a different assembly, then you should attach this attribute to that assembly. So that's it for this video. We will see you in the next video.